In this lesson, you will learn how the voltage, current, and resistance relate. Perhaps most important relationship between current, voltage, and resistance is called Ohm's law, discovered by George Simon Ohm and published in his 1827 paper, The Galvanic Circuit Investigated Mathematically. Ohm's principal discovery was that the amount of electric current through a metal conductor in a circuit is directly proportional to the voltage impressed across it for any given temperature. Ohm expressed his discovery in the form of a simple equation describing how voltage, current, and resistance interrelate. Alright, I'm gonna write the simple equations for you. E equals IR. This is the simple equations. So in this algebraic expression, voltage E, a symbol of E, okay, that is our voltage, is equal to current, that is a symbol of I, multiplied by resistance R, our resistance. Using this technique, this algebraic techniques or algebra techniques, we can manipulate this equation into two variations, solving for I and for R respectively. So I'm going to write I, solving for I, equals E over R, and solving for R is R equals E over I. So let's see how these equations might work to help us analyze simple circuits. Okay, this is my example of my simple circuit. There is only one source of voltage, the battery on the left here. As you can see, this the battery, and only one source of resistance to current, the lamp on the right. As you can see, this blinking here, electric lamp glowing, that is our lamp. This makes it very easy to apply Ohm's law. Why? Because if we know the values of any two of the three quantities, what are those? The voltage, current, and resistance in this particular circuit, we can use Ohm's law to determine the third. How are we going to do that? Let's see. First, we'll calculate the current, and the second is the voltage, and the last is the resistance. And as you can see in my simple circuit, the flow of electron flow from left to right, okay, from here up to here to the positive. I hope you have a basic understanding what is electron, and let's continue our discussion and compute the I for current. So what is the amount of current I in this particular circuit? So I'm gonna write I equals E over R. What's gonna be? So equals, that is 12 volts. Okay, the voltage is 12 over, as you can see here, E is represented by voltage is represented by E over 3 ohms. Okay, 3 ohms, that's our lamp, that is the resistance, over 3 ohms, equals, so this is the basic mathematics. You should divide the those values, so we get the 4A. Okay, 4A, that is ampere. That is a unit abbreviation for I, current, which means ampere or amp. Many people pronounce amp or ampere. It's up to you. V is voltage. That is the unit abbreviation for the symbol of E. For the quantity, quantity is the voltage, and with symbol of E or V, so that is the abbreviation. And resistance, we have the quantity of resistance, that is R, a symbol of R, and the unit of measurement is ohm, and this is the symbol is just like, this is an omega. Unit abbreviation. So again, quantity, symbol, unit of measurement, and unit abbreviation, you should be familiar with that. Current, I will repeat again, quantity, that is a current, voltage, resistance, the symbol of current is I, voltage E or V, and resistance is R, and the unit of measurement for current is ampere or amp, and for the voltage is volt, and the resistance is ohm, and last is the unit abbreviation for current is a capital of A, voltage, a capital of V, and resistance is this symbol, an, an omega symbol. Okay, but wait, before we move to the second example, I want to clarify that this first example is we already calculated the amount of current. We're looking for a current, an ampere, in this particular circuit with the given values of voltage E of 12 volts and resistance is 3 ohms.